Hello everyone. Today we have Agam Arora with us, and we welcome you in our day three of Azure Bootcamp. And uh, actually, Agam is working as a senior system engineer at Infosys, and he has really great experience with Azure. So happy to have you, sir, today with us.
Thank you, Chavi. All right. So today we are going to discuss the session three of AZ900 Bootcamp. In the previous 2 days, we have discussed in brief about how we are going to, you know, uh, the concepts of Azure and cloud computing and all that stuff. Now we are just going to revisit those things again, and now we are going to start with the session. All right, so this is my background. So I'm currently a senior system engineer at Infosys, and my primary domain includes working on cloud. I started off right off the bat in the cloud domain itself, wherein I work specifically in IaaS and PaaS services. Working on cloud migrations and cloud infrastructure is my forte, and I have also worked on cloud native DevOps and deploying dev QA environments in the company. And I have worked across various sectors like startups, SMEs, and the enterprise, which includes the finance, healthcare, retail, and many more. So these are my social links. You can connect with me over there. All right. So let's directly dive deep into uh, the concepts again and revisit those elements which are quite integral in the AZ900 preparation. So first of all, we are going to discuss the key characteristics of cloud computing. So first is the scalability, and next is elasticity, and then we are going to discuss agility. Then we are going to discuss the fault tolerance. So these are the elements. So now let's discuss in very brief about economies of scale. So Azure works in a very uh, minimalistic fashion with respect to providing these technologies at a very cost effective rate. How is that possible? All these resources could be provided to you in a very cheaper price than what is available on premises data centers or which is available through third party vendors. This is due to the economies of scale. So as you can see on the screen on the right hand side, if an individual purchases if we take the example of car here, then if an individual purchased it for $10,000, he has to also cater for the maintenance and insurance and other things. So it's gonna cost a bit more. Similarly, if we take in consideration the IT elements which we used back in the day in the 90s and early 2000s when cloud computing was not mainstream, people used to first of all get the servers and equipment and network infrastructure, and along with that the storage capabilities in their own facility. They had to pay an upfront cost or the capex for that, and they had after 5 years or 6 years they had to refresh that hardware again. So that was a very difficult thing to manage, and it's very expensive also, right? But in cloud, what happens is we are going to discuss that in economies of scale, what happens is that if, for example, Microsoft has their own data center and they have like 200 plus servers, they have purchased all that elements in bulk. So the price per unit becomes quite low, which is then reflected back to the customers with the very so the customers pay a very cheaper price with as compared to what they did on premises. So the cost per unit is lower if we use the cloud computing resources. That is the reason. So we saw in capex that because the customer uses their own infrastructure, there is a very good, big investment, and due to which the initial investment and the maintenance cost is quite high, and most of the resources are unutilized, or let's say unused, which is also another cost addition and wastage of the monetary resources. And also you have to take care of the hardware failures, software failures, all that stuff, and employ staff for that, right? You do not have any third party vendor managing it by just, once you buy the stuff, you are on your own, you have to manage it by yourself. So that is another, yet another cost. But when it comes to the operational expenditure, which is in the cloud, or specifically Azure, here we can see that the cost is just based on the usage. Whatever we uh, use, just like electricity on the cloud, we have to pay only for that. There is no initial investment required, and there is minimal maintenance because you just have your own cloud team or IT, cloud IT administrator, who is just managing all your uh, cloud assets in the single control panel or the Azure portal. And here there are no resources wasted in cloud, because you can stop those resources whenever you need, and you can start them again, or you can also switch to auto scaling in case you want the automation enabled there. So a very cost efficient and minimalistic approach which is there in the cloud computing. We have discussed this. The cloud is a consumption-based model. Here, the key characteristics are a pay-as-you-go model, and you can stop the resources whenever you require. So now let's discuss in brief. So we are now jumping to the topic of containers versus virtual machines. We are going to the topics where which we have not yet discussed. So first of all, let's discuss in brief what containers are in general. So we have discussed virtual machines beforehand. As you can see on the left-hand side, there is a physical machine which is the server in the underlying layer, and above that is the operating system, and then it is the hypervisor or the virtualization software, and the virtual machines are created with their own separate operating systems and the applications running on it, right? But virtualization itself, of a underlying hardware is a very good approach, but sometimes it also brings some challenges. Like for example, in dev environment, if we are developing an application, and there are a few people who are testing it out. So one is testing it out on the Mac, and the other one is doing it on Linux, and the third person is doing it on Windows. Each one of them has to download their specific dependency files or the specific versions. So for example, if the first person has to download the PostgreSQL version 3.5, and the other one, I'm just taking an example, I'm not sure of the exact versions here. So, and the for the Redis they have to do 5.6 or something. So after that, like similarly, if we go to the second person's machine, they have to download a different file. So all these, so sometimes what happens, whatever the developer created, it's not running on the tester's machine, right? And because the dependencies of that application are not yet, because it was initially created on a Linux machine, and now it's not running on a Windows machine. Similarly on the Mac. So this brings with it some challenges, and it delays the process of developing the application, right? But what container does is it virtualizes the operating system itself or we can say emulates the operating system, and it creates a dependency package in a package wherein your application can run anywhere, and it's quite portable. So whatever container is created, it's directly running on the uh, hardware. It's not or the base operating system. It's not running with underlying virtualization common software like VMware or Hyper-V. You can use Docker, and you can containerize your application, and it's quite portable also. You can use it on any machine. Primarily it was devised to run on any Linux distros, but you can also use it, and you can use it anywhere. So the main advantage of or contain yet another advantage is that it's quite fast to use, and it spins up in a very faster fashion than the virtual machines. So that's yet another advantage. So it also uh, what we can say is brings down the headache for, or removes that headache of the developer and the operations team. How? By because there are less errors when the tester is running it on the machine. They're able to do it because it has all the dependencies, it has all the options available, that this application is going to run here because it has all the options available. And so that is the advantage here. And comparatively in huge environments, if we have a very big IT infrastructure, there the containers pricing is also quite lesser in few cases. So this is the Azure service called Azure Container Instance. So what happens is that if a developer creates an application, they go to a container repository like Docker Hub or any other available option there out there. They create their own customized image, or they can use a public image. So what image here defines is the operating system and the dependencies. So let's say if an application its main dependencies are PostgreSQL, Apache Server, and Redis. So all that are packaged into a single component, and they are directly they are directly used to create that container instance. And this service is available on Azure. So it's quite simpler than going in with the virtual machine. It's quite you just have to first of all use your uh, customized image, or you can create it. You can go to the public repository and you can choose your image and use your whatever configuration you require, the vCPUs and the RAM, and then you can post it on, like you can deploy that application and expose it to the internet. So that's how it is. Next is the Azure App Service. So it's a web application service in the Azure environment. For example, if we are just want to create a web application and we want to host it, so it's a very good approach, and it's a platform as a service because here the developers, they first of all create a package uh, of that application, web application. We go to the app service in the Azure portal, and from there we can create nodes, and then we can expose that application on the internet. So we can create multiple nodes of that application, so that in case if there is an issue, or there is a dependency, or there is some problem, the one if a one app node is not working, it can jump onto the second one. So now we are going to discuss in brief the Azure Functions. So this is nothing but a function app. Function app is like for example, if we want to run small pieces of code, uh, in a web application. We do not need a specific server, or let's say a very big configuration, right? It's not an application, it's just a small piece of code, but it's to be run in the form of an application. Then we can use this Azure Function service or the function apps. What it does is, for example, if I have this small piece of code to add two numbers, I ask the developers to create a package of it, and then we can jump onto the Azure portal, find out where the search for the Azure function app, and then deploy this application. And whenever this function is triggered uh, of adding, then this code is run in the backend, and then the web application can work seamlessly. So this is a very cost-effective approach rather than spinning a new server or virtual machine, and because all of the most of the resources would be unutilized because it's just running a very small piece of code. So this service we can use for cost optimization and also maintaining that efficiency level in the cloud architecture. So next is the virtual network. We already discussed this, but let's revisit. So the main purpose of the virtual network is to enable the connectivity of the Azure resources along with the outside world, uh, which is internet, and also connecting it with the on-premises or the data center applications. So on-premises here refers to any third-party service or any service which is available outside the Azure environment, and it's a part of the company, but we need to connect that resource to the Azure. So it's a very good approach to, it's very essential approach to connect and manage your Azure environment and your whole IT infrastructure. So virtual network is just like a emulation of your physical network, which is available in the data center. Similar to that, we have to choose an address space. We can create the subnets from it, and within the subnets, we can deploy the resources. We can also connect to virtual networks with the help of Vnet Peering. So, which means that if the virtual machine on the left side wants to talk to the virtual machine on the right side, which is available in the second VNet. They cannot talk directly. They cannot ping to each other directly. They have to first of all be connected. So we enable once we enable the peering, there is a connection between them, and they can talk to each other. Similarly, we are going to discuss other elements of which are in the networking services of Azure. So these are the key characteristics as you can see on the screen. So if we want to do physical network infrastructure emulation that is done by the virtual network, you can isolate, you can create sections, you can communicate with the other elements, and you can also create routes to a specific service or internet, or you want to connect to on-premise. So Azure Virtual Net is the third point is quite important, that it's scoped to a single region. So if it's we are using a single region, like for let's say East US, so within that we have option of creating that Azure Virtual Network, and within that we have to create the resources. So it's not a global service like Azure AD. It's scoped to a single region. So you can create subnets here in the for the effective address allocation, and you can also create NSGs and ESGs, which we are going to discuss in the later slide. So let's now discuss the network security groups. So network security groups, as the name suggests, They are used to protect your network, and their scope is of the subnet. So they are just deployed outside the subnet, and all the resources inside the subnet, uh, sorry, so all the resources inside the subnet, they have this NSG deployed in front. So what it does is it has a certain defined set of rules, inbound and outbound rules, which you can filter on the base of address space, the port number, or the specific IP address, that this IP address is to be allowed inbound or it could be denied. So allow and deny options are available, which we can create according to our uh, application, and all those resources inside the subnet will be uh, will have to adhere to those rules. uh, let's say, and or let's say this virtual machine, we want to protect it from outside the networks, from because this application is exposed to internet, it has its own public IP address. Then we need to this is a public subnet. Okay, so what we are going to do is that in the NSD rules we are going to create allow and deny rules, where we can specifically point out the IP ranges. We can change the port numbers, that this port number specifically is to be allowed inbound and outbound access. So that's how we can protect our resources. Also, we can create NSGs between the two subnets. So if VM1 is compromised, then some attacker is trying to jump into the other subnet also, but it will have to go through the other NSG again. So this is how a second layer of security is enabled. So okay, so next one is the what VPN gateway, or the virtual network gateway. What it does is that, as you can see on the screen, we have two virtual networks here, and this is on premises. Uh, One second, let me just. Okay, I don't know why this screen is not visible properly, but there is this on premises over here. Okay, so what happens is that in the VPN gateway is used when we want to when we want to connect our virtual network resources to the on-premise. So if we want to create, first of all, we have to create a VPN gateway, which will be connecting from our virtual network to on-premises. Then it emulates that it's a part of the same network, and then resources can communicate to each other. So this is a very good step in the hybrid scenario, wherein we have 2 3 applications in Azure environment, and let's say we have a traditional Windows Active Directory enabled. So all both of them, they are connected to each other, such that with the help of VPN gateway, that they are part of the same network. Uh, but if we drop the connection, or we close the VPN gateway, and then they are not uh, they are not connected. So it's very secure mechanism, because it travels through the internet, but there is an encrypted connection between the VNet and the on-premises. All right, so let's check the comments if there are any. Okay, so Renee says that containers are more relevant than virtual machines. Uh, no, it's not like that. So, Rinesh, it depends upon the scenario what we are talking about here. Generally, if we are talking about monolithic applications, virtual machines are quite feasible. But if we are talking about cloud native approach, and we have very uh, big IT architecture, let's say we have a lot of options. For example, if we have like a very huge environment where we have hundreds of virtual machines or storage equipment, and the scalability and elasticity volume is quite high. For example, if it's a application which whose demand it jumps up in a very fast fashion, but and similarly it drops down uh, very quickly also, right? So it's a very big environment. We need to deploy the containers over there. It's a better approach. But in some cases, virtual machines are better and they are cost effective also. So we can't say that containers are more relevant. They are relevant in some scenarios where we have a lot of dependencies between the developers and the operations team, and the environment is quite huge. So if it's not a monolithic application, it's a very big application. Let's say it's a ERP or it's a hospital management system, and it's there we have lot of data. We have lot of we want to scale it up. We can we need to enable auto scaling. So because containers have the power of scaling in a very faster fashion than the virtual machines, then it becomes a very uh, then it's quite a good approach. But if the applications are very small, they have just we require only 4 gigs and 4 gigs of RAM and two virtual core CPU, then its virtual machine is better. Okay, anybody if anybody else has some doubts, they can post here. All right, let's move on now. Okay, so these are the key characteristics of Azure VPN gateway. One is that on-premises to Azure traffic over public internet connectivity, and second is the cross-region communication. So here it's a very important point that the Vnet peering is used if we want to connect two virtual networks in the organization. But if we have VPN gateway, it is used generally if we want to connect our Azure VNets and the resources within to on-premise. That is a difference here. Generally, we can use the VPN gateway also to connect between the two virtual networks, but uh, it's with respect to that particular scenario which we are looking forward to. But generally, VNet peering is used to connect two VNets. All right. So now let's discuss the Azure Load Balancer. So load balancer, as the name suggests, it is used. It is a layer. This one is a layer 7 load balancer, and this is used to uh, balance that the traffic which is incoming from internet or which is incoming from uh, to the virtual machines. So, for example, if the virtual machine we want to make sure that we have deployed two virtual machines here. So uh, what the load balancer does is that it makes sure that none of the uh, there is or resource health is always available. So what it means is that the virtual machine should not be in a dead state. It should be always available. So if the traffic increases, so generally that even to establish that even traffic. So load balancer, what does is that we have set the threshold of, let's say, 60% here. So 60% CPU utilization is here, and the machine is running and it's heating up. And after that, it starts to be slow. The application is so the users are being affected. They are complaining that the application is slower. So in that scenario, the traffic will be shifted to the second virtual machine, uh, and to balance it. So that's how it works. We can set the thresholds, and based on that, we can filter out that this is the option here. So uh, just to maintain the availability of the virtual machines, this is used, and it can we can create different rules here inside the load balancer options. We can also create different options here for the load balancer in the environment. So one is the layer 7 load balancer in the web tier, and the second one is the internal load balancer, which is in the data tier. So initially we saw that this balances this checks the traffic, the incoming traffic, and virtual machines are adhered to uh, with respect to whatever options we have. And similarly, if the queries are generated in the virtual machine, let's say it's a e-commerce application, so n number of customers are just inputting their data and fetching the details from the, so database is there in the data tier. So from the load increases on the first virtual machine, which is hosting a SQL database. So uh, here the internal load balancer will identify that this is alarming state, and we should shift the load to the second one. So that's where it does the job, and it evens or the balances the traffic to the second database, and then they can generate the query and then respond to this, and it goes back to the user with the required information. So these are the main characteristics. So even traffic distribution. So it supports inbound, outbound scenarios, and it is the main function of this is to maintain the availability of the servers and the other resources in the Azure Vnet, and also we can use it to for the scalability scenario. Also, load balancer is used to provide security. So next is the application gateway. So application gateway is generally used to balance out the web traffic or the HTTP, HTTPS traffic. It does the similar function to the load balancer, but the difference here is that at the backend there are application services. Also, App Gateway comes in with a feature of the firewall, where it defends the uh, virtual machines or the servers for being exposed to the internet, because whenever a request goes out from or the respond request goes out from the server back to the internet, then the IP is allotted from the app gateway and then it goes out. So it protects the internal assets with the help of this service, which is app gateway, and it balances this app service traffic. So because generally this is used for that service itself. So it's a specific web traffic load balancer. It comes in with a built-in feature of web application firewall with the version 1 and 2, and it has also the feature of redirection and session affinity. So next one is the content delivery network. So it's a very interesting service. We have discussed briefly, but now with the help of a diagram, we are going to understand in a very better fashion. So here, what happens? Let's see that we have deployed an app service, or we have deployed a US based e-commerce application, uh, so which contains these files, JavaScript, CSS, and some images. So, but this application is to be distributed worldwide. But we see that because this application, this is before the CDN technology. So let's say this application is currently in a residing in a server which is present in US location. So any user from India or Europe wants to connect to the server. So it will take a lot of time. So this is it's gonna take like 1600 to 5000 milliseconds to respond to that request. So if you uh, have we noticed this approach that if the web page is loading for more than 3 to 4 seconds, that irritation in the mind starts, that how much time it will take, that anxiety starts to kick in. This is quite problematic, especially with the when we are browsing for a thing we need, which is so uh, some of the IT engineers, they came up with a very good solution, which is called the content delivery network. So what happened is that with the help of CDN service, you can cache this website or the static content of the website to different locations worldwide, as you can see, which is shown in the form of blue dots over here. So one cache, this website is down cached here, and these are called edge locations or the pop locations. POP refers to point of presence. So Amazon and Microsoft and Google have their CDN locations worldwide present, and because Microsoft has partnered with Verizon and Akamai, which is the top CDN provider worldwide, so they provide the best CDN services ever. Wherein what happens that if a user is currently in India or they are in somewhere else, it does not matter that if the the main server is present in US or anywhere else, the latency will be quite less and the website will load in a very faster fashion. So that is the approach. So let's the example would be Instagram or YouTube or any other media website where we can see a lot of graphics like images, HD images, videos, and OTT platforms also, because they have uh, uploaded their content on these cache locations, uh, so that the users do not face that latency issue or any streaming issues, and the uh, user can access those elements uh, very fastly. So the response when the response times are quicker, there is a uh, happy face, and the feedback of the application is quite good. So this is the real world scenario of the content delivery network service. So it's available in Azure as Azure CDN. You can use n number of pop locations worldwide. It's present in India. There are like around 10 to 14 locations. Similarly, in US and South America and all those places. So these are the uh, key characteristics, like the minimizing of latency, POP locations, and delivering the web content to the users. So all the static content can be uploaded to these Azure locations worldwide, and from there we can move on. Okay, uh, let's check the comments. Does Azure have its own DNS server just like AWS? Okay, so Ravi Kumar, if that's I'm not sure I'm pronouncing the name correctly. So what happens is that to answer this question, I would say that DNS services works in a different fashion. So there are around like there are four there are a lot of servers to to enable this DNS service. There is root DNS, and there are many other versions. You can check this content out on online, wherein what happens that to process a DNS request, uh, the we are not sure that who owns it. It could be any third organization also. It's not necessary that Azure owns those DNS servers and the AWS owns it. So it's not like that. Azure and AWS are services provided by Microsoft and Amazon respectively. So it may be or it may not be the situation that they own this DNS server or not. So there are n number of servers uh, which have their specific function to cater to that request of DNS. So for example, I want to open a facebook.com. So first of all, it will that request will map. So there is a DNS resolver. Okay, so the DNS resolver will check that this IP address matches with this facebook.com or not. So and then it keeps going on, and the request, it keeps checking like a telephone directory. And once it finds out that this is the correct this maps with the this domain name maps with the correct IP address, then it goes back. It works with that HTTP request, and then it lands to that page to the user. So it's a very complicated kind of complicated process. So first of all, I request you to study that how DNS components work together and how they are gelled with the layer 7 services like HTTP and uh, other services like SMTP. So after that, you will understand that if how and who basically who owns this, and how many government entities are involved, and how many what is a top level domain, what is a subdomain. All these things you need to cater first, and after that you jump on to the next options like what is Azure DNS. So the basics have to be cleared first, uh, then you can move on to the specific service. All right, any other questions if anybody has? All right. So for reference, we have posted the links. Uh, Someone was asking that how DNS would work. So first of all, check out those links, and similar to that, you can Google yourself that how those services work and gel together. And after that, you'll be able to find out by yourself that uh, what is the whole process, and then you can jump onto the Azure services, specific services. Okay, so uh, let's just discuss the Azure Blob storage again. So this generally represents the binary large object file. So that is the full form of it, and it has three storage tiers. So first is the hot, which means it's frequently accessed data. So if a company, like we discussed, that if a company has a lot of images, videos, and they're frequently accessed. So if Netflix has, let's say, the top 10 trending movies, so they are going to put those in the hot storage tier because they are currently being accessed quite uh, in a high uh, in a next level fashion. But if we have some movies which are not frequently accessed, let's say in Amazon Prime Video or some other platform, we have some videos or movies which are quite old and nobody is watching them, or they have a very less rating. So they are put in the infrequently accessed data, which uh, so here the thing is that the cost of cool storage tier is comparatively lesser, and the down point or the which we can say the con of this cool storage tier is that its availability is lesser, and because it will take a very longer time to be processed, and if we request for this, then it will take a very longer time than the hot storage tier to be accessed. And the last one is the archive, which is like the zipped or rar version, or the very we generally keep it in that format. uh, any data which is backup, or let's say the very old data which we are just keeping for reference in case it's required, and the cost of this is even lesser than hot and cold tiers. uh, this is just for the generally companies keep the archive data uh, for the audit, or in case they are required to show the records to some company, uh, or they're just keeping it for compliance purposes. So next is the queue storage. So what happens is that the applications, they want to talk to each other, or they want to talk to some service. So let's say the application is Uber, and they want to talk to the Google Maps API. So uh, but currently it's busy, so it's not responding. So there what happens that if we deploy queue storage, then the whatever message that application wants to send, it's stored in the queue for a while, and once that it's the resources are free in that service, it will cater to the request, and it will map or send that message to that service, and then it can respond. So that's where queue storage is used. So it's a storage for very small pieces of data, or the messages which are given by the application. It's not written by any developer or anybody like directly. It's not typed by user that this is the service which I require. Applications are coded in such fashion that they can talk to the APIs, and then they can get the responses from them. So they are designed for the scalable processing. So next is the table storage. It is generally used for using the scalable service for no storing no SQL database, no SQL tables, and the queries can be processed in a much faster way. This is how it generally looks like. So if your tables have this, we have an n number of tables, we can store that and map it with the NoSQL service. So the main purpose here is for storing the semi-structured or NoSQL data, and it's designed for the faster access. So you do not just like we would require if we directly deploy on database, then we would need some dependencies. But here we do not need any foreign joins, keys, relationships, or any strict schema available. So it's a very faster process. So here we can see that all these storage types are uh, enclosed in a storage account. So if we want to provision some storage service, just we want let's say file storage, we just need to first of all create a storage account. That's a mandate. After that, we can provision the storage types inside that storage account. We can also choose a lot of options amongst the inside the storage account, that what is the access level, and we can choose the role based access control and all these things. So the last point here is the cost affecting factors. So the key characteristics include like the base cost, which is resource, what type of resources we are using. Every resource has a different type of cost. So if we have if we are monitoring and using the Azure Monitor service, we are checking the logs. So it's gonna help you to find out that which resource is costing more and which is costing less. Similarly, we have Azure Cost Management Service, which you can use for this thing. And next is the location. So generally, we see that East US or there are some regions in Azure like East US, East US 2, Central US, etc., which are comparatively uh, less expensive than the APAC regions. Why is it? Uh, we do not need to know. It's just a need to know basis thing that some of the locations are there or regions are there in the Azure portal where the virtual machines or any other resources quite cost quite much lesser than they do in the other regions like Asia or South Africa or Europe region. And the fourth point is the bandwidth. So we need to also monitor that the cost is also dependent on this factor, because the bandwidth or what we can call is the upload inbound outbound data. So outbound data we have to pay the cost. So whatever is going outside, whatever bandwidth or the data volume is just going outside Azure, there is a lot of cost involved. We can monitor that. And the last point is the savings, which means that we can, instead of going we can use the reserved instances instead of the pay-as-you-go model, uh, because here we have to reserve that virtual machines in a specific year or 1 year or 3 year term, and for that we will get a considerable discount. But the condition here is the virtual machines which are running 24/7, that uh, can be shifted to the reserved instance. So if we reserve those virtual machines for a, let's say, a longer period, then uh, we get more discount. So there are two options as of now: 1 year commitment and 3 year commitment, and the payment options are both monthly and yearly. So this is a one point. Second is the hybrid benefit, which is quite good for the Windows servers and customers using SQL servers, be it any version of it. Like in Windows Server, we have 2012, 2016, 2019, and now we are also uh, getting the we are will get the 2022 version. Similarly, in SQL, we have SQL Standard and Enterprise. So if the customer is having existing license in the on-premises, they want to migrate to the cloud, and they do not need to pay any extra license fee for their license. They can use their existing license. Given the condition, it should have software assurance. Then they can use the same license on the cloud. So if they're jumping from, they're shifting from the on-premises to cloud, they can use. They have to buy software assurance, and which is a very minimal cost, and then they can shift to the cloud with the existing license. Otherwise, if the customer is do not have the software assurance, they would have to pay for the hybrid benefit. Or sorry, what I meant to say is that the customer would have to pay again for the license. So I guess that is it from my side for today. We are about to wrap up this session. If anybody has some questions, they can let me know in the comment section. Could you please tell us common questions? You can refer to. Uh, you can just Google it. You will find a lot of resources out there. It's not like a fixed thing that this is the question to be asked. I i would rather say to rather than focusing on the common questions, you should focus on the basics, and you should understand the concepts. You should go to the Microsoft documentation for reference, Microsoft Learn, and from there, once you are just done with the topic, you do not need to go to these common questions, because this becomes quite confusing. If you jump directly to the for preparing from the MCQs directly, you will not be able to understand, and it will be a lot more confusion for you. So initially, just you'll have to just give it like, let's say, 15 to 20 days. Within 15 to 20 days, it's quite feasible time. You can prepare well, and just give 1 to 2 hours daily. And before jumping on to the Azure topics or documentation, just read the basics. So if it's a virtual machine, before that you should know what virtualization is, how these, what is image, and in networking, because a lot of students have issue. Uh, First of all, they should understand what a VPN is, how many types of VPN are there, and how it works. So they should understand the basics. Similarly, DNS service, and VPN gateway, and other services like storage account. They should know what a blob storage is about, and how DNS services work. So you'll uh, after that you when you jump onto the questions, it will be quite easy for you to understand. So that is a better approach. Next is the cost of certification, but it's all free. You can refer to the just Google it, and from there you can opt for the Azure. You can sign up for the Azure this certification training, and you can from there you have to attend those sessions for the AZ900 prep, and which is given by Microsoft, and these fundamental sessions, and from there you can get it. So there is a whole process, the whole uh, other for other these type of certification and all these queries, you can refer to the community team members. They can guide you further.
Thank you so much, sir, for such an amazing session, and it was a really great day three Azure bootcamp we had. So
Most
I'll
welcome.
just yeah, it's actually really insightful, and I really like the way students engage. So it's always amazing. Till then, the students can join in our Discord server as we will be having like we had a great session today, so we will be having an amazing quiz tomorrow on the topic on the same topic discussing about Azure only. So I'll be posting the link of our Discord server. You can join in our Discord server, and also we would be happy to have you all on our Discord server quiz tomorrow that's happening. And thank you so much again for all joining in. And thank you so much again, sir. Again, thank you so much.
Most welcome. Thank you so much.